Hi everyone, and welcome to the session. I'm Andy Shi from Alibaba Cloud. I'll be talking about Open Application Model, Application-centric DevOps approach. So in this session, we'll discuss the difficulties in the adoption of Kubernetes, especially to the end users, and our view or approach to solve it. Now, remember in the old days, we used to do everything in one application. We would write business logics, we would write the middleware, which is a database and message queues, and we will also have operational tasks in one application. But then the application becomes too big, and there are too many dependencies, and it's really slow to iterate through. And we decided to break it apart. So the cloud native movement really came and promised something great. It says offload your operational tasks to the platform. We'll take care of it. And not only that, you can also offload the middleware as managed service onto the cloud. So this architecture on the right, we will call that cloud native architecture. As you can see, the business logics becomes microservices. So this architecture really decouples operational tasks from business logic, minimizes the effort to manage resources that's not your own. Sounds great, right? But there's a catch. You got to be the expert of Kubernetes. Why? Because we used to do everything in our programming language. Now we got to deal with Kubernetes directly. And really sounds unfair. We often hear this. Kubernetes is too hard. Is it really? Well, I would say it's harder than it should be. Look at these two pictures. On the left side is a 1918 Ford Model T. On the right side is a modern day Ford. Which one of them is more complicated? Or let me ask this, which one has more parts? Of course, it's a modern day Ford, right? But which one is easier to drive? Ironically, it's still the modern day Ford. It's easier to drive. So how did that happen? And why it happened? Right? So it turns out that the key to adoption is really the level of abstraction or the interface exposed to the driver, and not how complicated it is under the hood. The modern day Ford didn't expect drivers to be professionals. Unlike the old days, drivers are chauffeurs. Today's Kubernetes, however, is, I would say, more like a Model T. It exposes low-level APIs, or we call them bolts and nuts, and expect the users to be professional. And that's not realistic and practical. Now that problem, I think many of us realized and many of us agreed upon. And that's why we see there are so many pipelines being built and being used for Kubernetes. And if you look at one side, it does seem to have the proper interface to the user, because the user is using the Git to interact and not Kubernetes. So the pipeline would just deploy this application onto Kubernetes. Now the problem is still there. Who will define the APIs or resources? Well, especially when you extend the pipeline to handle more DevOps tasks, since users don't want to deal with Kubernetes directly, right? These tasks, for example, would be rollout, canary deployment, monitoring, auto-scaling, etc. Now, one way for the pipeline to map the application to different Kubernetes resources is to do it in the pipeline automatically. But you need some kind of input, right, for those operational tasks or policies. For deployment, probably you can figure that out if you have a build script. But for auto scaling, for canary deployment, really you need another layer of abstraction and talk to the user. Now, the other approach, which is really popular today, is called GitOps, where we say the Git is the source of truth. That's great, but the users have to define all those APIs and YAML files, right? So it doesn't really shield the users from dealing with those bolts and nuts of Kubernetes. And don't forget, it's not just the raw Kubernetes, it's also the whole ecosystem, right? So we're talking about the CNCF landscape, right? How many projects are there? So what I'm saying is, regardless of how you're mapping it, you still need to build an abstraction layer, and it's hard to avoid that. So let's find out what is a proper level of abstraction to gather user input. We hope it to be great, just like the cars, right? Let's explore this example a little bit. So in this example, I'm wrapping two Istio APIs, gateway and virtual service, and create a new resource called Canary and expose that to the user. So the user will only specify the service, the versions, right? And of course, the weight of traffic. And they don't have to learn gateway virtual service of Istio. So it seems to be working. So that's really similar to what Linux share commands do, right? So the Linux share commands will shield users from syscalls. And in this example, Canary seems to be working just fine. And we got to be careful here, which is not to be too greedy, because we need to really pay attention to the level of abstraction or automation. If we automate too much, the pipeline and toolchain will become really opinionated. And that creates silos. And silos are bad. Silos are bad for users, since there's no one-size-fits-all solution, right? It's all opinionated. They need to maintain several pipelines or toolchains. But if you think about it, that's still okay as long as they're willing to learn and willing to pay. It still beats dealing with Kubernetes directly. But it's really bad for platform or pipeline builders, because their day two lives will become harder. We're forced to reinvent the wheels every time, even though we should not be, right? There are so many projects around Kubernetes or cloud native ecosystem. Remember the cars we talked about earlier, right? In car industry, even though each car looks and feels differently, under the hood, they share many parts. It's generic parts. Now, we're not saying that every pipeline should behave the same, but similarly to cars, there should be common APIs or common resources that can be taken advantage of. Right now, these objects or resources are just not abstracted at the proper level. So we have to redo it even though they are the same. Now, so far, we have identified one of the major difficulties of Kubernetes adoption is the level of abstraction of Kubernetes APIs. Now, abstracting too little is bad. Abstracting too much is also bad. So how do we decide the right level of abstractions? Well, I'm going to suggest some principles. First, we believe the right level of abstraction should reflect the cloud-native architecture. The cloud-native architecture really decouples the operation tasks from the workloads. And the workloads can be your microservices or can be managed service. But if our resources are abstracted accordingly, it will help to let proper developers and operators focus on their own jobs, right? In turn, it will make the teams more focused and be efficient, which is a goal of cloud native movement. What happens, or what about the application-centric view, right? Application-centric view is a view from the perspective of applications. Now today, most the tools are focusing on the perspective of infrastructure and cluster. Now we're not saying that they should change their views or their GUIs, right? But we're saying that if we keep the application-centric in mind as a guiding principle, it is easier to make the right choice when it comes to the right level of abstraction. We're going to talk about how to abstract next. So in this talk, I use the term APIs or resources. They're all coming from Kubernetes. Now, there are upstream native resources and there are custom resources, right? Both are running in the form of controllers and expose them to the users in the form of APIs. So in this example, I just call them CRDs because they're more abundant. There are different ways to build the abstractions. Some will do it in the backend, like we are doing here. We created another CRD, but you can also do that at front end. Really, the choice is about how flexible it can be when it comes to do the abstraction. Nevertheless, we would like to introduce a middle layer in between, or in this case, it's just the CRD modeling layer. So this term, modeling, is borrowed from application development. There's a term called data modeling. So what data modeling is, there's always a middle layer between the user interface and the database. It's rarely, very rarely that the user interface will directly modify the database. So by adding this additional layer, it gives the platform builder the power to manipulate the underlying CRDs or APIs. And here are some examples of how we can abstract the resources. Now, for the first one, we will just combine the deployment and service into a web service workload, since web services will always expose some ports. Now, abstractions doesn't always have to go up. It can break down things as well. We would decouple, in this example, the Argo rollout into a workload and a rollout. Why are we doing this? Again, think of the cloud-native architecture. There are workloads and there are operational tasks. So we're breaking them accordingly. And sometimes abstraction is just translation. The Knative deployment, unlike the Kubernetes deployment, it will create revisions. What we are doing here is really to automate that revision logic and only expose the fields that people are familiar with because they deal with deployment more, right? So these are the same fields that they will use when specifying a deployment resource. So these are some examples of how we think the abstractions should be done. And so far we've discussed the principles and methods, so the why and how. If you agree with this, you think this makes sense, I would like to introduce to you OAM, the project that I'm working on. OAM stands for Open Application Model. It has three principles. Open, that we would like to have building blocks, not silos. Application means that we want them to be application-centric. And model means we are modeling the APIs or CRDs or resources. In short, OAM is a spec and a framework to model the Kubernetes resources, not just the raw Kubernetes, but the whole ecosystem, into the right level of abstraction. Now, next, let's examine how it helps to achieve such goals. Now, in OAM, it has certain concepts. One of them is component and workload. These are the generic form of what we just saw in the micro services and managed services that map to the cloud native architecture. Now, platform builders can define their own workload schemas here. You may choose to simply wrap around the deployment, right, and to filter out those fields that you think that's not relevant, or you can combine deployment and service, right, into a web server workload. The next part is called traits. Traits are operational tasks. They are attached or instantiated onto components. So the traits are things like scaling, rollout, route, cert, etc. Now, who developed the traits? Well, they normally come from platform builders, or you can use the modeling CRD methodology to modify the existing CRD from another project. But the key here is that they are abstracted at the proper level, right? You remember what we did for to Argo rollout, right? For end users, they don't have to learn a particular project, right? And for the platform builders, they don't have to reinvent the wheels all the time. So attaching this trait onto components is done at the API called application configuration. Now on the right side, this is one example. It's very straightforward. Now OAM really promotes application-centric approach. This is a logical diagram of what just happened. But imagine that we have dozens or hundreds of applications like this, right? So we will have dozens or hundreds of components and trades to manage. These resources have to provide some kind of metadata or information to be manageable. And that's why OAM is a spec and a framework. It specifies the needed information and guidelines for resources to be defined as workloads and trades. Also, it regulates the metadata needed to manage a large amount of resources. For example, which trades will conflict with each other, right? Many trades actually will conflict with each other, so you need to see the warning messages. OAM also currently provides an SDK to help the development of trades and workloads. Eventually, what we want is to have an ecosystem or a repository of open source workloads and trades so that all platform builders can benefit from. Now, the goal of OAM is to help platform builders. It provides the building blocks for platform builders, but it will not dictate what a pipeline or toolchain or path look like or what it does, right? This is still the job of the platform builders. And also, it's not the final design. OAM is a middle layer. So you're free to add another layer of abstraction at the UI level, let it be a GUI or CLI, right? And decouple even more from the backend, the API level. And of course, you're responsible for the core business values, right? We are only providing the building blocks for the common features. If you're interested in this, please join us, and we'll be more than happy to have you. Here's some information of OAM. We have a bi-weekly community meeting, and we have a Twitter account, and you can check out the Git repo or the website. Please follow us and join us, and we'll be happy to facilitate. Thank you.